been trying to figure out how we could generate lift at the edge of our atmosphere. And I've got a pretty good grasp of how planes fly with their polar moment of drag and polar moments of inertia, and how lift is multiplied through the length of wings and its surface area. I think that at the edge of our atmosphere, of course, atmosphere thins out, keeps thinning out, right? But so as pressure over a wing lessens because there's a high flowing boundary layer of air, that slower moving air under the wing has higher pressure, and that generates lift. Well, thinking about diffusers and how they slow air to increase pressure, I'm wondering if you didn't flip a wing. This sounds crazy. If you flipped a wing at the edge of our atmosphere, sort of thing, and then you have a system of diffusive air that can slow air in certain places, and then if you could increase airflow, then the natural airflow, to keep that same boundary layer, since there's no atmosphere above the wing, that's lower pressure, and you're increasing pressure under the wing. That should generate lift at the edge of our atmosphere. I don't know how to test it. I've been trying to figure out an experiment to prove it. But I mean, it works in theory. Of course, you need thrust, obviously. You always need thrust with flight, but of course that's the main issue, right? How do you generate enough lift to maintain that effect of space? Because space doesn't have any pressure, so it's not like it's pulling you out to space. You know? Otherwise, you could just circle the globe indefinitely, using gravity to accelerate you, maximizing your inertia, and limiting and lowering drag, right? So you have as little drag at the top of the wing as possible. So your polar moment of drag is under the wing. And it's not even a polar moment anymore, it's diffusive air, right? So then it's like using ground effect at the edge of our atmosphere to generate lift. I'm gonna keep thinking about it. It's fun. It's interesting.